Okay, now I want to take a look at solving problems using unit analysis or dimensional analysis. What I want to look at first is a brief review of some physics terms that you should have learned somewhere along the way in freshman physics or physical science or chemistry. So work is force times distance. Energy is the ability to do work. So work can change into energy and energy can change into work. And power is the rate at which you do work or use energy. That is, it's work over time or energy over time. Now, I'm going to focus here on problems using energy and power. So I want to write this definition out a little bit, and I want to talk a little bit about units with you. There are lots of different units for energy, so there are lots of ways that you can convert. Understanding dimensional analysis and unit analysis will help you do that. Going back to the definition of work, work is force times distance. The SI unit of work is the joule. That's also the SI unit of energy. Since it's a force times a distance, that is a Newton, the SI unit of force, times a meter, the SI unit of distance. We're not going to focus on this as much, but I really want to focus on this definition of power. Power is how fast we use energy. The SI unit of power is the watt. That's probably a familiar term with you from electrical appliances. They're often measured in watts, the power, whether it's a light bulb or a dryer in your house. Now, a watt is a joule, the unit of energy, per second. So I want to make sure you know that, have that committed to memory. A watt is a joule per second. We're going to use that, and if we understand the units and what they measure, we can use unit analysis to solve problems. Now, we can also solve some of these problems using a formula. That's perfectly acceptable. So we can solve power problems using a formula. Power is energy over time. But if you understand it, we can avoid the formula altogether and just work with the units. A watt is a joule per second. Let me give you an example. Okay, for my example, let's say that we have a 40-watt light bulb. That means when the light bulb is on, it's using power at a rate of 40 joules per second. Let's say that we leave our light bulb on for 10 seconds. And I ask how much energy is used during that time. One way to do that is with the formula. I don't want to do it that way. I want you to think about unit analysis. So if you look at what we have, we know that we have watts, which is power, and we have seconds, which is time. But what I was just trying to get you to remember is that a watt is a joule per second. And what I've asked you to find is how much energy is used. And you should know that energy is measured in joules. So I want to take 40 joules per second in 10 seconds, and I want to end up with joules. And I want the joules to end up on the top. So I want to keep joules on top, but I want to get seconds to cancel. So let's look at the units. Here seconds is on the bottom, here seconds is on the top. If I multiply those units, they'll cancel. That's a really easy multiplication. Multiplying by 10, just put a 0 on the end. And you should be able to see that in 10 seconds, our 40 watt bulb will use 400 joules of energy. This is the method that I want you to use. I want you to follow the units. A watt is a joule per second. You multiply by seconds, you get your answer in joules, which is what you measure energy in. I will show you real quickly, that's the same as using a formula. So power is energy over time. We knew the power and the time. We wanted to find the energy. So you could rearrange. Say the energy is the power times the time. But if you look at what we did, we took our power and we multiplied by the time. We didn't need the formula to tell us because we followed the units. We followed the dimensions. Hopefully that makes sense. Let me give you one other example, make it slightly more complicated. We're going to stick with our 40 watt bulb, but now instead of leaving the bulb on for only 10 seconds, we're going to leave it on for 30 minutes. So I'm going to have a 40 watt bulb burning for 30 minutes, and my question is the same. How much energy is used in that time? So I want to find energy. I want to find joules. Since I know I want to find joules, I want joules on the top. I have two numbers. This one has joules in it, and joules is on the top. So I'm going to start with this number. Now, to get joules, I want to get rid of seconds. So I need to multiply by a number of seconds. But I only know minutes. What I can do is I can just think, oh, I can convert this minutes to seconds, and then I can get my other unit to cancel. So let's come up here to time, and we'll use our unit analysis method to make a unit conversion. I'm going to get rid of minutes and get seconds. 60 seconds in 1 minute. 6 times 3 is 18. I have 2 zeros. 1,800. Now, using my unit analysis, if I multiply, the seconds will cancel and I'll be left with joules, energy. So 40 times 1,800, let's keep it simple. 4 times 18, 4 times 10 is 40, 4 times 8 is 32. 40 plus 32 is 72. There's a 0 as a placeholder, that's a 10. 2 more zeros, so 3 zeros. So 72,000 joules. Notice, we can work the problem without knowing the formula if we know how to follow the units. That's not always true, but it is often the case, and that unit analysis method should be very helpful.